Hello, everybody. I'm Andy from ThinkMo. Now I am teaching the CCIE course. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is: what does a type of LSA of OSPF describe? So in the process, first of all we need a simple LSA. Give an explanation. LSA, we call it Link State Advertise. Link Status Notification. OSPF, it belongs to Link State Routing Protocol. It's fundamentally different from. We refer to the Distance Vector Routing Protocol. It transmits an LSA. Distance Vector Routing Protocol. It passes routing information. Link state describes the link state. Different LSAs are described. The link status is different. Let's start with type-1 LSAs. I will show you later to explain more types of LSAs and some of the information they describe. So today our main objective is type-1 LSAs. The second aspect is what is the use of LSAs. It's usually used to describe what we say. Topology information or routing information. Topology information is used to build the SPF tree of the whole OSPF. SPF trees we talked about in the last video. You can think of it as SPF topology information. So what is the topology? Routing information is used to describe OSPF routes, like the network number, the next hop, and the mask overhead. This is the information required for a route. The third aspect is: under what circumstances can a type of LSA be generated? First, we need to know, what exactly does a type-1 LSA describe? It mainly describes the direct network information. What is the direct network information? It's what network I'm connected to. And of course it includes the topology information we talked about and routing information. I've already activated 2 devices here, and now they're in the down state. Although in fact they are connected, but it didn't open. So in the process, we can see that now. Based on our view of OSPF Link State Database, from this command, we can see the type of LSA in this. We also call it a router LSA. Its type is router. So this is what you saw router saying. It is essentially a type-1 LSA. So in the process we can see that kind of information. LSID, we call it Link State ID. This is called the Link State ID. It's one of the names we mentioned. So the second aspect. This is the router of ADV we mentioned. ADV means advertise. It's an announcement router. We all know that LSAs need to be described. The router that describes it. Where it came from. We'll assume it came from someone. There are some fields. We're not going to explain it. I think you should just focus on these points. We can look at LSID. ADV router. All routers are 1.1.1.1. This is its header information. And we can see that down here. There's a link ID in there. The link ID is 1.1.1.1. Then the data is 255.255.255.255. The following link type is stubnet. It's the tip that we're talking about. A dead-end network. You can compare that to a terminal device. A terminal is a device connected to the last terminal. So let's put it in the network. It's a network at the very end of the connection. Because I configured it on the AR1 router. The IP address of the loopback interface is 32-bit. So the link type inside is stubnet. What it describes is routing information. Its network number is 1.1.1.1. The mask is 4255S. We can look at it. Indicates the IP address of the interface. How is it configured? Now I can turn this link on. And then we can see. It also describes some other information. And then there's actually the third question. There's an explanation. When is a type 1 LSA generated? The first must be running OSPF. The second is to describe the direct link information. Description: the OSPF process was declared. That's when the information can be described. This is the concept we're talking about. This link was not enabled just now. To prove the point we just made. So let's turn it on now. The link type of subnet we have just seen. In type 1 LSAs. It is also what we call a router's LSA. What it describes is routing information. This link is then enabled. On AR1 and AR2. I also pre-configured it. Let's say AR1 and AR2 set up neighbors. At the same time, get all the direct network information on AR1. They are added to the OSPF process. Next, let's look at one type of LSA. So in the process, we now see an additional transnet. It has ID, data, and metric. That was stubnet describing the routing information. Translate specifies the topology information. Its link ID is 12.1.1.2. It is the IP address of the interface of AR2. For example, the IP address of the peer end. And we can actually look at it on the AR2. This is the 12.1.1.2 I configured. The data field on AR1 is the IP address of its interface. So if you look at AR1, it's G000. Information configured 12.1.1.1. And then 255.255.255.0. So transnet describes the topology information. For a type of LSA link type, there are several kinds of it. So let's do an extension here. First, we just learned about stubnet. Its link type. What is described is routing information. And transnet. It describes the topology information. There are also two types of routing information. One is P2P. The other is virtual link. It is also called a virtual circuit. These are the two we have in this issue. No more explanations in this video. I will explain accordingly later. So this is the same thing as. I leave you with two questions. P2P and virtual link. Type of the link. That also joins the virtual link. What kind of information do they describe? That's all for today. If there are any other skills you would like to learn, feel free to leave a comment. Or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.